Today's lesson is inequalities. Our essential question is, what makes an inequality? Pretty easy.
So here's our first question to put over on the left-hand side. What is the difference between an equation and an inequality? All right, so an equation is something we've used a lot in this first part of the unit. Something like x plus 5 equals 13. If we were to solve this, we would find that our solution is x is equal to 8. 8 is the only number we can put in for x, add 5 to it, and we do get 13 as an answer. So on our number line, we could show our solution as the number 8.
Now that we've mastered that, we're starting to change it up a little bit. An inequality has many answers. Because there just isn't one answer, we need to show all of the possible answers. So if the statement was x is less than 3, x could be 1, x could be -3, it could be -5.5, -6.01, whatever the case may be.
Really close in. It could be 2.999999999, right close to the 3.
There's just an infinite amount of answers that it could be. So inequality has many answers while an equation only has one. If you could get the difference between those two in your notes, that would be great.
So next is we're going to see some vocabulary or some symbols that are used for inequalities. Jot this question down. What does the extra line under some inequality symbols mean? After this next part, you'll be able to answer that question. And
a lot of this is just review, but some of us still struggle to remember which way the crocodile is actually going. So if you can make this kind of 4-column notes in your midsection and label it the way we have our chart labeled, you'll be ready to go.
All right, so our first one is less than, and this is how I remember it. It kind of looks like the capital letter L. It kind of opens in the same direction as a capital letter L, so I remember that's less than, the L for less than for us. Greater than is going the opposite direction. It's opening up to the left-hand side. And then we have these two other ones. Notice this one is a less than symbol, but it's got the extra little line underneath of it. This one is called less than or equal to. So it's okay to be smaller than a number, but it's also okay to be equal to it. So that's that extra bar.
In our last example, it could have been 3 if that line was underneath the inequality sign.
And then our last one here is greater than or equal to. So it's okay to be bigger than a number or equal to it. So that extra bar tells us that it could be equal to the number as well. So we have an example of each one of them. 3 is less than 5 is how we would say it in words. And a vocabulary term to jot down in the same column is the phrase fewer than. It's another phrase that also means less than. It means something smaller than your number. Then we have this one, 8 is greater than 4. So we'd read that, but we could also use the phrase more than to mean the same thing.
It's a little trickier when the line is underneath it. 7 is less than or equal to 10 would be our example, and that is true. It could equal 10 as well. But this time our key words are at most. So you can be at most 10 years old to ride the ride, or you can be at most, I don't know, I lost it, go.
And then the last one here is 12 is greater than or equal to 9. So another word or phrase that you might hear that means the same thing is at least. Like you have to be at least 48 inches tall to ride the roller coaster. That means you could be exactly 48, or you can be greater than that.
Or we have to have at least 25 people to hold the party, something like that.
All right, so now we're going to go ahead and see how do we test a solution in an inequality. So of the numbers 5, 6, 7, and 8, which is a solution to the inequality f plus 2 is less than 9?
So we're going to go ahead and check to see if f could be 6, 7, or 8 right now.
Or 5.
5. If f was 5, 5 plus 2 would give us 7, that's a 2, on the left. 7 is less than 9, so the answer 5 could work. If f was 6, 6 plus 2 is, what you doing, boy, is 8. 8 is less than 9, so 6 could work as well. 7 plus 2 is 9. There's no equal sign underneath the inequality, so that is a no. And 8 plus 2 is 10, which is definitely not less than 9, so 8 is a no as well. There we go.
Just slow today. So notice that it's not like an equation. There's not just one possibility. It could have been one of these. It could have been all of these. It could have been none of these that are solutions. But you have to show that work and how you checked each one of them as you go along.
Is the given value a solution to the inequality? So go ahead and write down your 3 examples, and then we'll go through to figure out if the x or the w or the d is actually equal to a number that works. So x is less than 13. If it's 8, 8 is less than 13. 8 could be a given solution. True.
All right. Next one. 6 is greater than or equal to the sum of w plus 4. So in this case, we're going to plug in a 2. 2 plus 4 is 6. Is it true that 6 is greater than or equal to 6? That one would be true. It's not greater than, but it is equal to. So as long as it's one of those, it works as a solution for us.
If d is 8, we're going to go ahead and put the 8 in for d. So the product of 3 and 8 is less than or equal to 18, would be 24 is less than or equal to 18, and that answer is not a solution.
So we have to see your work and how you plugged it in, found your value, and then told us whether or not that makes a true statement or not. I think that's it. Oh, yep.
Have a good day.